Okay, wrapping this unit up on measurement. We talked about accuracy, talked about precision. Yesterday we talked about uncertainty, because we know there's limits to measuring devices. I mean, some are much more accurate than others, but usually the ones that we use are okay, but not really precise or accurate, but they do the job, okay? But obviously, I mean, we want to be as accurate as possible, especially in things like in areas like manufacturing, right? Because if we're not accurate and if we're not precise, you can find yourself going out of business pretty quickly, because you're going to be spending money on a lot of things that you have to redo again, and that's not good for your problem. So when objects are manufactured, no two are going to be exactly the same size. They can be very close, okay? You know, but there's always going to be just the slightest difference, okay? But we want to just minimize that difference as much as possible. Okay, so we're going to talk about tolerance. Tolerance means basically, what will you allow? What are you good with? Like, your measurement has to be between something and something. Like, I'm okay if my measurement is between these two values. That's what tolerance is, okay? The actual value that I'm trying to get to is called the nominal value. Okay, that's the one that I'm trying to achieve when I measure something, is the nominal. But there's always going to be a little error, okay? And that little error we call the tolerance level. So you can see we've got an example here where we've got wheels made for a particular type of vehicle, okay? So when you put the bolts on, when you're putting the wheel onto your vehicle, obviously you want the holes in the tire to match the bolts that are on your vehicle. Otherwise, you're not going to be able to get your tires on, okay? And you want them to be fairly snug too, okay? So when these wheels are constructed, and even when the bolts are constructed that go on the vehicle, they have to be made within a certain tolerance level, okay? If it's outside that tolerance level, it's like, no, that's unacceptable. That's going to decrease the quality of the vehicle, okay? And we don't want that. So like, here's an example, you know, wheels are constructed, they must be made with a tolerance level of plus or minus 0.001 or 1/1000 of an inch, okay? That's pretty specific. Okay. And then you can see we've got another example of carpenters building a house. We've got ones where, you know, the tolerance levels need to be quite tight. There's not a lot of room for error. And one area that you see an example here would be like for an aircraft. Because if you got things too loose or not fitting, that's going to be extremely dangerous, especially with air. Okay. All right. So the nominal value or the target value, the tolerance level, are always given by the designer of the object. Okay. And its tolerance levels will determine the allowable limits of the size of an object. So let's say we've got a measurement calls for, and we don't have the units for this one, but it's 8.231 plus or minus 0.002. What are the measurement's upper and lower limits? Well, to find the upper and lower limits, we take the nominal value. So for the upper, we take the nominal value, 8.231, and because we're going upper, we add the tolerance that is given in this case. So we get 8.233.
And then to find the lower, obviously, we do 8.231 minus the tolerance. And that gives us 8.229.
So whatever this is being used for, our tolerance is pretty low. It has to be pretty close to each other. Okay, like there's not a lot of difference between the upper limit and the lower limit in this one.
In example 2,
well, maximum and minimum mean the same thing as upper and lower.
So maximum, we take the nominal value 92 plus a quarter.
I mean, you can change that in decimal if you want to, 0.25, or it's just 92 and a quarter.
Minimum is going to be 92 minus a quarter.
And again, you could change it to decimal. 92 minus 0.25 is 91.75, or as a fraction, it would be 91 3/4. Okay, but the decimal equivalents are more than this. So to calculate the tolerance, notice it says here, it's the difference between the maximum and the minimum limits. Okay, so you definitely want to, I don't think that formula is given to you, but we'll talk about creating reference sheets starting next week, because this is our last lesson. So for example 1, the tolerance would be 8.233 minus 8.229, which is 0.004. Pretty small tolerance. Okay, that's something that looks like something that needs to be quite precise. For example 2, the tolerance in this case, we use the decimals, would be 92.25 minus 91.75, which gives us 0.5 or a half. So we're being more flexible with example 2. Whereas we're being less flexible with example 1. Okay, how is tolerance shown? Well, there's different ways to show it. Okay. So we already talked about this one, plus and minus. Okay, so tolerance can be shown as plus or minus. And you calculate the tolerance by going plus, going minus, and then subtracting those two. It may be shown what's called limit dimension. Okay? So what it does is it states the maximum and minimum limits. It doesn't state the nominal value. So it could look like this, or it could look like this. So if we had one that looked like this, we're saying that the minimum is 7.75 and the maximum is 7.79. Notice we're not given the nominal value, but we can find it out. All you do is you just add these two numbers and divide by 2 to find the nominal value. Or in other words, it's the mean, the average of the upper and lower limits. It may be shown like this, okay? Where this is the lower or minimum, this is the maximum. So that's limit dimensioning format. Again, this doesn't show the nominal value, but you can calculate it by adding these two together and dividing by 2.
something called bilateral. Bilateral looks like this. So it gives you the nominal value. Okay? And then it gives you how much we are willing to go up and how much we are willing to go down. Notice it doesn't necessarily have to be the same. Okay? So this has a nominal value of 52.6. Okay? We're willing to go up to 52.6 plus 0.3, which is this. And we're willing to go down to 52.6 minus 0.1, which is this. Finally, so this is bilateral, okay? Because you've got two numbers here. Very similar, but one of the numbers is going to be 0. Very similar to bilateral, but one of the numbers could be the maximum, in this case, could be the minimum. So this means the nominal value is 636, and we're not willing to go up anymore. It cannot be higher than 636, but we are willing to go down 5 to a minimum of 631. Okay. So knowing these notations, we want to calculate the upper and lower limits and the tolerance. Okay. Sometimes we're given the nominal value, sometimes we're not. We don't have to really worry about that here. Okay. So, what's the upper limit here? 56.3. 56.3. It's 56 plus 23. 56.3. What's the lower? Yeah. 56.0 minus 0.3, which gives us 55.7. And therefore, tolerance, I need the upper and lower before I find the tolerance. Now I can go upper 56.3 minus 55.7. And that'll give me a tolerance of 0.6.
Can you penalize if you put 7 0 instead of
If you put what?
the 0 after the 3? If I put 55.7.
No, no. If you did 55.70, you're fine. Yeah. Unless you're at, unless of course you're asked about precision, but that's not being asked here. B is pretty easy because you're given the upper and lower. This is the first type of notation. Okay, so the upper is 6.34. The lower is 5.23. So the tolerance is upper minus lower. Which would be what, 1.11? Yeah, 1.11.
Is there ever going to be a case for this fine?
Or what? In these type of questions, probably not, but there could be. Like we are, well, actually, I shouldn't say that because we are going to do some questions where there are units in this lesson. Okay, this one. What's the upper?
5.3 plus 0.4 gives me 5.7. What's the lower? 5.3 minus 0.3.
This is a negative number.
It just means subtract. Yeah. Yeah, it doesn't mean subtract negative. Yeah. So 5 or 5.0. Yeah, 5 is fine. So the tolerance is 5.7 minus 5.0, which is 0.0. This one, well, the upper is 3.65 plus 0.07, which is 3.72. What's the lower?
This is 0.
3.65 minus 0. It's just 3.65. So therefore, the tolerance is going to be 3.72 minus 3.65, which is 0.06. Okay, so now we're going to throw some units. So we're going to talk about tolerance levels with area and volume of shapes. Okay. Any complicated formulas you will be given. Like you don't have to remember how to find the, say, volume of a sphere or the volume of a hemisphere or things like that. You only have to know some simple ones like these. Okay. All right. So how do we deal with this? Like to find the area, normally we just go 6 times 2, right? Length times width to find the area. But we have to find the maximum area it could be, the minimum area it could be, and the tolerance. So you actually have to put it, no, you don't times tolerance. So the maximum area, I know, it's a fair amount. The maximum area is, well, what's the maximum this could be? 6.5, so we get it by doing 6 plus 0.5. Times the maximum the width could be, 2.1, or 2 plus 0.1. And that gives me, so 6.5 times 2.1 gives me 13.65 centimeters squared. Now I have to do the minimum here. Thank you. To find the minimum area, I got to find the minimum the length could be, so 6 minus 0.5 times 2 minus 0.5. So that gives me 5.5 times 1.9, just wait, it gets there. Is 10.45 centimeters squared. So the tolerance is going to be the max or upper minus the min. So 13.65 minus 10.45 looks like it gives us 3.2, yeah, or 3.20 centimeters squared. So yes, in this case, you needed the units. That's it. Okay. Well, it'll get a little crazy for the next couple of shapes. Now, why do I have YouTube?
Wait, click on.
I'll bet you, no, this is one of my, no, thank you.
It's so good. I don't shop in the Coach Marshall. It's down now. Here, you work my goodness. I need it.
I don't know why this is here, but it's bothering me. Okay, I guess I just gotta leave it here. All right. So here, notice with this one, you're given the formula. Okay. So yeah, we're given the radius. That's a little confusing. Technically, we're given that. Wait, let's start. Okay, the maximum. So we gotta keep track. 1/2 times 4 times pi times whatever the radius of this shape is, the maximum it could be. 12, because it's 12 plus 0. Square. Plus 2 times pi times the maximum radius, which is 12, times the maximum height, 28.7. Plus pi times the maximum radius, 12 squared. Yeah, that's pretty good. I would suggest that we do this. Let's do each one. And let's round them to 2 decimal places. So remember, exponents first. So you got to do 12 squared, then you got to times by pi, then you got to times by 4, and then you got to times by 1/2 or divide 2. So 12 squared is 144 times pi times 4 equals, and then divide that by 2. You should get about 904.78. Yeah. 1/2 is the same as divide by 2. 904.78.
One section. 178 plus.
Should be right. The next one, 2 times pi times 12 times 28.7 should give me 2,163.93. Remember, I'm using the pi key, not 3.14. And then this one, you got to go 12 squared and times it by pi. So this one you should get 452.39. At least those are the numbers that I got. And then when you add them all together, huh?
I just get like a number in the five, which one? Aaron. Hold on a second. brand. Pretty hard.
So that's what I get. Just figure it out. I think I know.
The negative, the billion, and then something. So, you look at my uncle, that changes it from this.
Okay, so that's the max. Guess what?
I've already started telling them.
What's the radius? 9.5, you said? No, 11.5. Plus 2 times 5 times 11.5. What's the minimum height? 28, right? Times 28 plus pi times 11.5 squared. Do the same thing with that. Just calculate all three of them, round them to 2 decimal places, and then add them up. Eight 30.95. Okay, hang on. Squares.
Oh, my gosh, I didn't do it.
Oh, I got 830.95. And what did you get?
I got either, so I've done 11 squared instead of 11.
Oh. This one works out to 2023.19. And then 11.5 squared times pi works out to 415.48. So if we add those together, we're going to get 830.95 plus 2023.19 plus 415.48. That gives us 3,269.62. Remember, it's surface area, so we're centimeters squared. And then, of course, to find the tolerance, we have to do the max 3521.1 minus the min 3269.62. And that'll give us a tolerance of minus 3269.62. Should be 251.48 centimeters squared. Oh, wait a minute. No, it's fine. Q5, yeah. The only mistake I made is centimeters, it's feet. Sorry about that. So that one's a pretty complicated one. The last one with volume is a little bit easier because it's a much easier form. So, I mean, this is Yeah, this is like the most complicated you're gonna see. Okay, so this one, and again, you're given the volume. So we have to find the max volume, the min volume, and subtract the two. So it's going to be pi times the maximum radius, which would be what? 3.02 squared times the height of 7.35, yes. And that will give us our answer. Let's go to two decimal places again. So remember, do the squared first. Squared times pi key times 7.35. Whoa. What'd you guys get?
Like it's 596.
So 60. This is inches. And don't forget, this is cubed now because it's volume. But yeah, that's good. The minimum volume would be pi times the minimum radius, which is 2.98 squared times the minimum height. Looks like 7.25.
Yeah.
Okay, and I'm just going to write max is 3 plus 0.02, just so we know where those numbers are coming from. Min equals 3 minus 0.02, so that gives me 3.02, and that gives me 2.98. And then here the max is 7.3 plus 0.05, which is 7.35, and the min will be 7.3 minus 0.05, which is 7.25. That's got it. 202.26. Sounds good to me. So finally, just the tolerance. 210.60 minus 202.26. It was 8 point what? 34 inches cubed. Good. All that. All right.